Okay, next one here, we're going to be kind of doing some proportional things and things like that there. So um, let's see here. On this first one here, they tell us you got if x to 12 is the same thing as y to 26, then what's another way to write it? You can just kind of do this here. You can say x to y is the same thing as 12 to 26 right there. So that's kind of a weird one right there. The reason being is the things when you cross multiply are still going to be across from one another. X is still across from 26, and then the 12 is still across from the y. So that's why you can swap those around right there. Those are mathematically equivalent. So next one here is using the fact that the sides here, AB to BC, are going to be proportional. So we can do this here. We can go and say, okay, well, AB, well, actually, really, you should draw it this way. It's not going to make a difference, but you can say 12 to, and I guess we're trying to find BC. We'll call it X here for right now. So 12 to X, and then is the same thing as 18 to whatever this side is. Now to find that side, it's just 33 minus 18, which is going to come out to like, what is that, 15, I believe? Yep. 15, and then you can cross multiply and divide. I think something with that big of numbers probably would have a, that'd probably be on the calculator section. So 12 times 15 is 180, and that does divide rather evenly. So that'll be x is 10, or in this case here, you can say BC is 10 units. That'll be it there. 27 will be a repetitive problem there of that AB to BC. It's the same thing as AE to ED right there. So really just saying 6 to X and then equals 12 to 4. And there's a couple of ways you can think about it there, but I'll just do regular cross multiplication and then divide, and that's X equals 2. Some of you are wondering, like, why can't you do 6 to 12 right there? You can, but then you would have to change the other fraction and call it X to 4. But when you cross multiply, once again, the 12 and the X are still across from one another, and the 6 and the 4 are still across from one another. So there's multiple ways, I guess, to set them up on these here. And of course, you can have both fractions flipped as well. Okay. Next thing here, they tell us that these two quadrilaterals are similar. So first of all, we're going to find the scale factor between the two right here. So what I would do is find the two sides that match here. So this 10 right here, it appears to be the shorter side. And that's going to match up with the shorter side of this other parallelogram right here. So that's 8. So typically, I'll go new over old. So here's your old, here's your new. So that's going to be 10 over 8, which we won't actually leave. Go ahead and always reduce. That'll be 5 over 4. So you'll get full credit if you go 5 over 4 on that one. Now, as far as finding these individual values of x, y, and z here, just depends on what you're finding. For x, what I would do is set up a proportion. So x matches with the 12. So you say x to 12, kind of like that. Well, then find two other sides that you have, which we used earlier. We used the 10 and then the 8 right there. So I'll put 10 to 8. Okay. Now you can use 5 over 4, like your scale factor right there if you want to do that. But usually I just write that and then use my calculator. 8x is 120. Fairly certain that goes in even. 120 divided by 8 comes out to x equals 15. So I'll get you that side right there, and that would be that side, that proportional side of x. Y, well, I guess we'll kind of do the same thing. Well, actually, you know what? If this side here is 8, this side right here must also be 8 right there, since it's a parallelogram. And then z, you got to figure out what angles match here. So z right here, if that angle is 135, this angle's got to match up there with that. So we'll say z is 135 as well. 35 degrees. So the angles all actually match, and then it's the sides that are proportional. That probably wouldn't be a terrible thing to write here. Sides are proportional. Angles are congruent. Okay. All right, let's do another one here where the figures are going to be similar. So the following figures are similar. Find the scale factor and find x. So what I would do is find two matching sides there. I'm going to go with the shortest given side right here, which looks like it matches with this side right here. So you got a 40 to 10 ratio right there when you reduce. That's a 4 to 1 ratio. So you can say the scale factor is either 4 to 1, or you can just write it as a regular 4 right there. So that's your scale factor. And then next we can go and set up a ratio. If you want to use the 40 to 10 again, you can. Or if you want to use 4 to 1, the scale factor, you can use that. Either way, you'll go 4 to 1 or 40 to 10. That'll equal, and we're trying to find x. X looks like it matches with 3 here, so we'll go x to 3. And then you can cross multiply and divide. That'll be x is 12 right there, just like that. So there's your scale factor of 4 or 4 to 1, and then side x.